mentioned here in other episodes how cyberkinetic warfare begins with ICS systems under attack. Take down a water or a power plant, and population it becomes desperate. Take down their communication systems, and they become even more vulnerable. Such an attack wouldn't be overt. It would be a long game. Devices would be compromised, yet sit dormant, performing as they always had until someone gave them a new command. Such a scenario was exposed in 2023. Telecommunications devices in the U.S. territory of Guam were found to have had exploits that, if executed, could render the island cut off, isolated, something that a hostile nation might want. Here's the BBC on May 25th, 2023.
Yes, this is a joint advisory from 5 Western nations saying that a hacking group, which they say is linked to the Chinese state, has been carrying out this quite stealthy campaign to hack into infrastructure, things like telecoms providers, transportation links, and particularly Microsoft saying that they also believe that as well as espionage, which happens all the time, there is also the possibility, they say they only have moderate confidence, but a possibility that there was the intention to be able to disrupt communications. Particularly interesting, I think it singles out the island of Guam, which is a US territory in the Pacific, as being one place where this took place. Now, the implication of that is that this is more than just normal espionage, the kind that happens between nations, but there's the possibility that China was developing some kind of capability perhaps to disrupt those communications if, for instance, there was a crisis over Taiwan and it wanted to disrupt the ability of the US to take some kind of action or communicate in response.
And here's former FBI Director Christopher Wray testifying before Congress on January 31st, 2024, about Operation Volt Typhoon.
Dangerous actions, China's multi-pronged assault on our national and economic security make it the defining threat of our generation. Now, when I described the CCP as a threat to American safety a moment ago, I meant that quite literally. There has been far too little public focus on the fact that PRC hackers are targeting our critical infrastructure, our water treatment plants, our electrical grid, our oil and natural gas pipelines, our transportation systems, and the risk that poses to every American requires our attention now. China's hackers are positioning on American infrastructure in preparation to wreak havoc and cause real-world harm to American citizens and communities if and when China decides the time has come to strike.
It's interesting that while the Biden administration made this a top priority, the Trump administration has been largely silent on the matter, with cybersecurity investigators from several government agencies assigned to this actually removed from their jobs in recent weeks. This is a story about how proactive defense, cross-sector intelligence sharing, and risk-based decision-making is necessary before tangible attacks urge urgent responses. I'm Robert Vamosi. This is Error Code.
So I am Mike Welch, Managing Director from Morgan Franklin Cyber. So Morgan Franklin Cyber is a end-to-end cybersecurity solutions provider across multiple sectors, from financial services to healthcare to critical infrastructure. We do GRC, governance, risk, and compliance. We do AGIS, which is architectural engineering, CORE, which is resilience, identity access management, and we also have what we call our Cyber Fusion Center, where we provide 24/7 monitoring for our customers.
So Michael has an interesting past. He's been in ICS for a while.
For about 20 years, been in cybersecurity for about 25 years. And early on in my career, I had the opportunity to work with a few utility companies, starting back in the 2000s, NextEra, Florida Power and Light, and Duke Energy, which is where I was able to cut my teeth on industrial control systems, distributed control system generation, transmission, substations, control centers, which then really built that appetite for continuing to want to learn more about other kind of industrial control systems.
So the energy sector, in some ways, is ahead, in my opinion, of some of the other critical infrastructures, because we've gotten various regulations that have been around much longer.
That would be correct. The energy sector is regulated by FERC and then by NERC, which is then broken up into a number of different regions. It started out in the late 90s, early 2000 with the 1200 series, which were optional. And then they actually started building out the NERC CIP standards, which companies had to then start complying with. So they've been doing this for probably 20 some odd years from a regulatory standpoint.
I've talked to people in the water utility space, and I'm wondering, is there any other utilities that can learn from Energy's experience?
I believe so. I mean, water utility, unfortunately, doesn't have a lot of regs that drive them. Compliance and regulations become a vehicle for organizations to get proper budget to be able to secure their critical infrastructure. The way the NERC CIP standards were built, there's 14 different standards now. So other industries could go to like asset management or supply chain and benefit from what has been originally created and then enhanced over time. As the attack surfaces continue to change, the requirements and the regulations also change. So I think other industries that are starting to step into those types of controls could learn from the experiences that the utility industry have already been doing for a long time.
And those are largely industry-driven standards, correct?
Yes, they are industry-driven standards, correct.
Recently, with CISA, we've started to see some federal attention. Is there a place for both?
It would be great if there was a federal standard that encompassed and covered all. Unfortunately, a lot of the different operations of the different types of sectors do vary. So they do, I think industry specific is where it will continue to go, but there are great frameworks out there. CISA has the Center of Internet Security has its CIS 18, and then you have the NIST CSF or an ISO standard, depending if you're multinational. Those frameworks can definitely be applied across multiple sectors, but the regulations are usually built for a particular industry or sector. I think so. There will be a little bit more difficult to try to apply that across all because it's not one size fits all. You've been doing this for a while, right? If you try to do it that way, you'll have more risk than the reward.
So what drives compliance in the industrial control sector?
What drives it is because of the functions that these systems provide, right? If you look at power, I mean, it's what gives us electricity, what keeps the lights on. So you need to have a set of the regulations to make sure entities are doing what's best for the business, for the greater community. A lot of times when we talk about industrial control systems, we're talking about safety is first, right? Safety is paramount. So having some regulations really are looking at safety, then maybe availability, then integrity and reliability and things like that. So because of the potential impact or consequences that could happen if there was a breach at a power plant or a water utility or a healthcare, because they have a lot of OT, really drives the reason for regulation. And once you have regulation, you have to have compliance to meet it.
So with those consequences, there's an obvious consequence of a brownout or a blackout and potentially patients dying in hospitals. Are there monetary consequences for not following the regulation?
100% across. I mean, there are different fines across different sectors. I mean, there's HIPAA from a privacy compliance perspective, but when we're looking at industrial control systems, when you look at NERC-CIP per se, there are large fines that could be pushed down to a responsible entity because they didn't meet the compliance side due to a blackout or a brownout. But then there's also audits that they have to go through. And through those audits, and they may be in multiple regions, so they may be going through audits through 3 or 4 different regions. And then there's FERC on top of that. So they have to make sure they're doing right by their employee base, by their customer base, because they are audited on a different cycle. So it's not just the brownout. The brownout would bring it out completely quickly, but they also have audit cycles to make sure they're doing what they should be doing on an everyday basis.
So one thing I've observed is the energy sector and water and gas and other utilities are local to a large degree.
I would say water, oil, gas, probably more localized. Energy, because the way they do sharing and grid, like across the grid, other than Texas, like because they're isolated, they have their own grid for the most part. A lot of other energy companies, they may have to do load sharing just because of they could be in an outage or there could be an issue at a plant. So I wouldn't say they're as localized as something like a water utility or wastewater or oil and gas.
Where I'm going with this is that we've seen some of the attacks that are starting to focus on ICS, and they've focused on those local districts.
Correct. And a lot of those attacks start at the business side, right? And I think we see a lot of stuff in the media that a water company or a utility has been breached. And maybe it was breached on the business side and it didn't get over to the industrial control side. A lot of sites are centralized, right? So they're being controlled by, like if we look at utility, like a generation, they're being controlled by a control center. So if a bad actor was able to get into that control center, they could cause catastrophic consequences because they could impact multiple sites. When you're looking at water, the water, if they got into there, they were able to do something, they could impact probably that little bit more of that localized region. But it is a concern. I think if you talk to different people out there, attacks on industrial control by themselves has been probably minimal. There's been more on the business side trying to work across, but there are proof of concepts out there and some cases where you could compromise a PLC or an RTU and cause it to do something it's not supposed to do. So I think it's opening the eyes of a lot of folks that because we're dealing with industrial control equipment, those types of attacks will present themselves in the near future.
When I talk about crimes against computer systems, I think of the barrier to entry. How hard is it for a bad actor to do this? And when we talk about PLCs, we're talking about very specialized technology, very specialized RTOS and so forth. I'm thinking more of the Colonial Pipeline. That was a network attack, and they shut down the OT system just to err on the side of caution.
That goes back to understanding the whole business impact, right? Understanding the dependencies that are upstream and or downstream. Because a business impact could impact the operational side. Perfect example with the Colonial Pipeline. They were being preventative. I don't think maybe they understood the impact that was going to have across the whole entire pipeline in the Northeast, right? The impact there was tremendous. So it is understanding the business and what the plants or pipeline or water, what functions it's serving, and then how the business could impact it. Because there's a lot of conversation out there about convergence, right? We try to stay away from convergence because as you start bringing the two together, it opens up more risks out there. So that is the things we as practitioners really need to continue to do is understand the consequences if something did happen. Because if you know it ahead of time, you could put in playbooks and put in processes to remediate that or block that or prevent it from happening beforehand.
So something like Colonial Pipeline, which was a ransomware attack, is a known entity. And we've seen this. It's been repeated in other industries and so forth. but we've had some attacks that are more dormant.
Yeah, I think when you mentioned earlier with the typhoons, like the Volt Typhoon and even Salt Typhoon, they living off the land, right? They're attacking network devices, routers from telecom and other different areas to gain a foothold. Once they have a foothold, they're not there to do things immediately. They're learning. Once again, the terminology is they're living off the land. They're expanding. They're setting their what they're going to be doing. Which was one of the why Volt Typhoon and Salt Typhoon got so much publicity out there, because of the number of devices that were potentially impacted, maybe for a future attack, which is, from a cybersecurity perspective, is something that we never want to see. And living off the land is an art. I think as practitioners, we're getting better at identifying things like that. I don't know if we share that information well enough yet, which could help each other from an intelligence side. But the bad actors really work well together. To your question before about PLCs, in the past, you had to be an expert. Today, they share information and they make tools available that you don't have to be that great attacker anymore. You just have to be able to get a foothold in, and then you can use ransomware as a service. You can use these toolkits that are being developed to get your foothold. And then if they get a foothold, then they can sell that to somebody else that wants to take it to the next step.
So let's break that apart. What is Volt Typhoon?
Well, I mean, when you look at the media, Volt Typhoon was state sponsored by China, where they infiltrated or started getting around the critical infrastructure sector. And there's 16 sectors in critical infrastructure, right? So I think they targeted communications, utilities, manufacturing. They were supposedly in the grid for a long period of time. That they used the terminology of living off the land. They had a lot of different levels of access. And I forgot actually how they were identified, but what could have happened because of the footprint or the foothold that they had in those different sectors. They're only doing that it's a nation state attack, right? They're doing it for if in the event that war or escalation, that now they have the ability to really kick off a campaign because they're already in those environments.
And Michael mentioned Salt Typhoon. I think there's also a Flex Typhoon. Are these variants?
I think with Salt Typhoon, I'm not as familiar with Flex. With Salt Typhoon, it was more towards the telcos, right? They were targeting the telcos. They actually were starting, because as we look at telcos, they're in every household, right? They're in everywhere, every router. So they actually were able to start to get to what you talked about before, the networking side. They were able to get to these routers, these other types of networking equipment, in telephones. So even to getting to information that could be used for deep fakes and all these other types of attacks. A lot of high profile folks were targeted in that because they had so much data in their hands to do stuff with, which to me is more concerning and more dangerous because of the technology and with deep fakes and what you're able to do. Even to the point, if I remember correctly, they actually got a lot of intelligence information, which some of it may be old, but they could use that for future campaigns, future attacks.
So staying with the telecom attacks, for example, were those in the firmware or are they in the chipsets?
I think it was, honestly, I don't know if it was at the chipset level. It was more at the firmware level, just gaining direct access to these devices. Some of it was default passwords. Some of it was just misconfigurations. Unfortunately, when you have a large number of assets that are going out to different locations, and a lot of this case, if it's home, if it's small businesses, they come with a standard package. And then that standard package isn't always the most secure, at least back in the day. They're getting better today at implementing stronger passwords, removing services that no longer need to be there. So just because of that type of device, they took advantage of just the configuration, the firmware level. Once again, the chipset, I'm not an expert on that, so I don't recall if it was down to that level.
I'm inferring that because I heard the telecom companies say that it would cost them billions of dollars to replace all the hardware affected.
100%. And unfortunately, cost is a factor in remediation. Sometimes as a business, you have to make that decision. Are we going to put this money out to pull these back, to remediate them, get all new devices out? Unfortunately, the answer sometimes is no. They'll take the risk. It's a business risk, but that risk, nobody thought it would get to that volume and now have such potential impact across multiple sectors and home users and the information that they were able to capture, I don't think was understood at the time.
I've heard in the financial sector as well, where they allow a certain amount of fraud because it's easier to write off that fraud than it is to mitigate it. With the utility, it's kind of like they're saying these are all theoretical attacks. We don't need to jump and act today. Unfortunately, we do need to jump and act today.
I do believe a lot of folks need to see it actually happen before they're willing to accept it could happen. Proof of concepts are out there. I still believe there's a group or people out there to say, hey, it hasn't happened yet. If it's designed properly, if we're using the Purdue model, if we're air gapping, if we got one-way firewalls, we can mitigate all this. Because if you design a site properly with segmentation, they should never be able to do a C to C. Well, I mean, the command center, like calling out to the command center, which is usually needed to be able to execute these kinds of attacks. Because a lot of our control systems are nested deep into an environment, it's hard to get out. Now, not every sector has the same level of security as you will see in the power industry. There's some OT systems that are directly connected to the internet. Maybe they're not as critical. So I do think it maybe depends on the criticality of the environment to determine what level of control, segmentation. But as a practitioner, if you leverage that Purdue model and you build it out and secure it properly, you can limit your exposure greatly, that even if somebody was able to get to something, they can't really do anything. And if you have the right controls and monitoring, you would identify it before anything actually really happened. I think that's the mindset that a lot of folks use today.
So I talked to somebody recently who was telling me that the Purdue model was based on the 1990s way of thinking about the internet. I wonder, does Michael still advocate for the Purdue model, having a DMZ and total separation?
I mean, a lot of folks, it depends on the industry, right? A lot of folks are moving to the cloud now, right? So the Purdue model may not always work with the cloud. I like it personally from a perspective of if you do your separation and from level 0, you have your sensors and actuators. A lot of times they're hardwired, right? They're not IP based. But as you work your way up at different levels where you put your PLCs, it may be an older school model way of thinking, but if it's implemented properly, it actually definitely assists in the segmentation of your environment. So it reduced any kind of, I listened to one guy, he talked about the blast ratio. If you have an attack or insider, outsider, how can we reduce that ratio of where it can expand to with proper segmentation at those different levels, assist in that. If you had a flat network, there's no stopping a bad actor.
It got me thinking in another direction. So this movement to the cloud, there are newer devices in the field as well. They have a lot more resources built in them than ever before.
There's various types for sure. They have a lot more intelligence in them. Maybe not the same capacity from a processing perspective, but they're meant to do a certain thing, but they have a lot of intelligence. And a bad actor who knows what they're doing can definitely take advantage of that. and try to use that as a point to get to the next spot. So you got OT, you got IoT, you got IIoT, right? It's going to continue. Each one of those enhances the attack surface and enhances our risk. So you always have to just keep that in mind. The edge is no longer the firewall, right? The edge is firewalls, almost becoming non-existent. I still think they're needed, but that edge is getting further and further and further.
So I'm curious why we might not be seeing as many botnets taking advantage of operational technology, given there's additional resources and lots of cases where they're not as well protected.
I think botnets are out there. I think it goes back to the monitoring capabilities. It may create more noise than those types of devices are used to. That if there is proper monitoring going on for those OT, those IoT devices, that the providers, the SaaS providers that are providing those, it could be a Ring camera, right? It could be a Nest thermostat. If they're monitoring their devices and they're building out their monitoring capabilities around behavioral and they start seeing different things, I think we're getting better there on identifying. It's just what we do with that information is where we still need to improve. So botnets themselves, I see them more attractive on traditional assets in large scale versus being used in smaller IoT devices where their function is limited. So the opportunity to identify it would be quicker.
So a manufacturing plant in Michigan is not going to be taken over by a botnet because it will be monitored and stopped.
Hopefully it should be. I can't always guarantee it, but if that manufacturing facility, it has the right capabilities, the right design. I mean, there could be a denial of service or something targeting them, but they should not be part of a larger botnet that's doing some other action against another organization. I think bad actors would find other areas for that, because that manufacturing is being monitored and the normal versus abnormal traffic should be identified. And there's a lot of great tech out there to assist those kinds of organizations in identification, prevention, and then eventually reaction.
So we've identified some of the attacks that are out there today. As a practitioner, what does Michael advise for best practices?
There's a couple of different areas that I think are foundational. Asset management is critical. It goes back to the adage, if you don't know what you have, how do you protect it, right? How do you know what's normal versus abnormal? So having a asset management and inventory, and not just in a spreadsheet, knowing what it's for, what its function is, because those all provide information to either your own internal SOC, or if you're using a SOC as a service, the more information you have of what you know, goes back to the dependencies of the functions of each upstream, downstream. If you know that, you can build controls to protect, prevent, identify, monitor, react, right? You can build that. Without knowing that, you're fighting a losing battle. To me, identity is critical. It's easy for us to say, hey, we can use MFA, we can use single sign-on, we can do all these things with multi-factor. In the critical infrastructure space, that's not always the case, right? We can't always have single sign-on or MFA because there's shared accounts, there's safety involved. It could be life or death. So that 1 second that you weren't able to authenticate because you didn't have your phone with you isn't always acceptable. So you have to build in other means to make sure you're using authentication, strong authentication. That's why I think we still have the password today. We talk about password complexity, is because that the great technology around MFA and single sign-on isn't 100% accepted in critical infrastructure yet because of life safety. Remote access, understanding who's coming into your environment, how they're coming in, why they're coming in, is critical in the critical infrastructure space. it really shouldn't be open. Every OEM vendor or vendor that you have shouldn't have carte blanche remote access into your environment. It's almost, they should check in, right? Hey, we need to come in. We have some maintenance work. We have to do it remotely, whatever that may be. It shouldn't just be open. In the past, I believe it was. We're getting better on that secure remote access. And I think the other one, I mean, you can go on and on, but the other one is, because the legacy systems are still so paramount in the critical infrastructure space, how do we protect them? Vulnerability management, patch management isn't always allowed. You might have a piece of technology that the vendor that created it isn't even around anymore. So how do you patch it? And it might be a crown jewel, might be critical to the operations, and we can't replace it yet. And unfortunately, it sounds odd, but it's a scenario that happens more often than not. So understanding how to remediate that is also critical from how do you protect that environment. And whatever you build, you just have to make sure you can defend it. If it's the Purdue model, it's segmentation, you have to understand how do you recover in the event there is something, because you don't want to make it so complex that the recovery becomes, you're not able to do it because your environment is so complex. So it's that slippery slope. You want to segment and build it out to prevent bad actors from moving laterally, but you also want to make sure you can recover if you ever have either accidental or intentional attacks.
So Michael mentioned not being able to update and immediately thinking of medical devices, and control around that has been kind of an opposition. Like in network, we just push out a patch very quickly. But in OT, we design these things to last 20 to 30 years, and we don't think that we'd ever need an emergency patch to go out.
100%. And like you said, you talk about medical devices. Now you're talking about, it might be a pacemaker. It could be something in a person that you can't just go there and say, here you go, because you don't know what that's going to be. So that's where every sector is a little bit different. And a lot of times you'll see, hey, you have to have a patch management process and you have to patch it within X amount of days. Yeah. Traditional assets, yes, but you have to have exceptions or other processes for other kinds of devices. If I try to patch the firmware on a relay or something, that could have catastrophic problems. Now, it should be built with redundancy and all those other different things that would be preventable, but it's not always the case. Patch management, vulnerability management isn't one of those things that it's one way fits all across all industries. It really has to be built around the particular industry, the particular device. Is life, is safety involved? And that goes back to the whole consequence. And the Idaho National Labs has their whole CIE, consequence-driven, cyber-informed engineering, right? If we can start from the beginning and talk with engineers and cybersecurity practitioners and technologists working together, we can build what we call security by design rather than trying to bolt things on later on.
Earlier, Michael mentioned something around architecture, and I'm wondering, does that involve identifying the remote access?
A lot of times when architecture is, because you have to know where it could be an internal engineer, it could be a OEM vendor, really where they go, where they land, how they get from point A to B, how do they authenticate, all goes back to traditional architecture. How do we design this network or this environment into segments to protect our equipment? Once again, not every equipment is the same. An actuator is different than a PLC, which is different than an HMI, or at that top level where you have web services and all those other things. So being able to know where somebody needs to go, having the least privilege model, not giving everybody admin access just because it's easier, really is important. And you do a lot of that in the architectural side of things. You design, right? When you go back to, I used to work for a company, Burns McDonnell, it was an engineering firm, right? You do all your design up front. You get your design approved. That goes through security. That goes through a number of different iterations before you even get into actually getting all the equipment. You do factory acceptance testing, site acceptance testing, all for those reasons to make sure that the systems function as they're designed, but they have the controls in place, and the controls don't become roadblocks. They're actually just enabling the business to work more securely.
I'm very familiar with the software development lifecycle. Is there a similar hardware development lifecycle?
I wouldn't say I'm an expert there. I would probably say yes. I mean, unfortunately, a lot of our hardware come from other outside the US and stuff like that. So you don't always have that level of input on that. But I would do say with like going back to the utility power, their regulations require you knowing where all the components come from, even at the application side. So if you have software, libraries, third-party libraries, anything else, you have to know where they're all coming from, how they're maintained. They did push that down to the hardware side as well. So you can't just say, here's a chipset, here's a processor, here's a controller, here's memory that was purchased here. You have to know where it came from, how is it maintained, because unfortunately, there's back doors that can be embedded at the hardware level.
I'm immediately thinking of the automotive industry, where everything is cataloged and recorded, so they know exactly what part to recall. Basically, that rigor doesn't appear in any other industry.
Not to that level, no, especially as the cars are getting more intelligent with EV and all that stuff, leveraging PKI and those models to help build trust. I don't see any other industry that is at that same level. I do think power, the generation, transmission, substation side of it is starting to try to get there. It will be a period of time because it's about maturing, right? The auto industry has been in that process for a long time about recalls because how many cars, how many drivers. So you have to protect that population. Where the other sectors may not have that same level of population that they're protecting. Power is one that is. So they are starting to build out the controls to require more control on where you're getting your equipment from. Where is it being manufactured? And a lot of that goes to the OEM vendor. Because if you're looking at a power plant, they may use an Emerson, they may use a GE, a Mitsubishi, whoever it is. They're relying that OEM is now going to be required to provide what we call now a software bill of materials or a hardware bill of materials. And you have to know what each individual component, because if we ever need to go back, we have some kind of inventory to refer to. Like I said, I think I highlighted before, and I think you acknowledge it, the Idaho National Labs, right, with the cyber-informed engineering, consequence-driven engineering. I think, and a lot of that is driven towards the utility, the power space. I do believe it's something that can be applied across other sectors. I know they're working a lot with universities where how to embed security into engineering at the university level or at the college level. So when these engineers are coming out, they're thinking about security versus really just thinking about engineering. So I think that's an area that there's a lot of opportunity to grow as an industry across the board. I think resilience, understanding the whole BIA, business impact assessment, resilience, recovery, operational resilience is one of the most critical things we're facing today because of the number of ransomware attacks. It's about how can we be resilient. And I think in the past, it's been a little bit more taken for granted. I think there's a big area there and a lot of conversations around operational resilience, what it means, how do you apply it.
Could Michael explore that a little bit more?
I think the model can be used on any sector, right? It starts with that inventory, understanding what you have, understanding, they call it the BIA, understanding the business impact that that device has. Because one of the things today is we all don't have unlimited budgets, right? So if we have the opportunity to know where the biggest impact, the most consequence we can then start planning on how do we build resilience around that? How do we engineer the controls to support that? How do we build the network segmentation, right? Understanding all those pieces and parts help build out what your operational resilience is. And then conducting tabletops, right? And putting it to practice, learning. A lot of times we wait for our tabletops or wait for exercises until something actually happens. Well, if we actually did exercises and did things and test them, identify where we had gaps, after action reports, we can start layering in opportunity for improvement through that evaluation, including our supply chain. And all that is around operational resilience, right? Understanding what you have. How do you build it? Know what it does. How do we respond? What is our fallback? Do we have to, in a lot of the critical infrastructure, there's a lot of manual fallback because a lot of the systems are still manual based. They're building out technology, but they have an option to fall back manually. If we're 100% technology driven, it may not be a manual fallback. It might be, so what do we do? So I think that's when we talk about resilience and operational resilience is understanding what do we do in the midst of attack, because we're always being attacked. How do we respond? Do we shut down? Do we operate as normal? Who do we call?
I'm glad Michael brought up the manual stuff, because in talking with water utility companies, it's something that they do. They try to see whether they can turn the valves manually.
Which is great. And for folks like sectors like that, they're very underserved. They have, their budgets are minimal, right? So they, more than anybody, have to fall back to those. So having those opportunities to do those tests help them tremendously. Now, there's been a couple of attacks with water companies, right? I think that's probably the closest industrial control sector that actually had an attack that got possibly to the control room, the movement of the mouse and this and that somebody identified. But knowing how to fall back, because they're usually 1 or 2 man teams, women teams, small tech teams. So they don't rely only on technology. Which is critical. I wish more sectors actually did do that, where they have the ability to test. Now, power plants don't always have that. You might be able to test if you're in outage or getting ready to go in an outage. You have multiple units and you bring a unit down to make sure the other unit can withhold. Oil pipeline, you could do a lot of manual testing with valves and stuff like that. When we talk about healthcare, in the IoT side, there's not a lot of manual interventions when you have those pacemakers and some of that equipment. So it becomes more about testing in labs and centers of excellence to really understand the equipment so you know what to do, when to do, and how to do it.
I'd like to thank Michael for coming on the show and talking about his 20-plus years in industrial control systems. Hey, if you're enjoying Error Code, tell a friend. I'm sure there are other people out there who like narrative information security podcasts. And I'd really like to hear from you. Go to errorcodepodcast.com to get more details. And tell me what you like, and even what you don't. I've got some great episodes coming up. We'll have more on Volt Typhoon, Salt Typhoon, and hacking utilities supply chains. Subscribe today. I don't want you to miss out.